right, so we are getting ready to celebrate in 2 more days the landing of the Mars rover Perseverance. It has been on a 6.5 month journey to get to Mars. So we're going to talk about some different pieces of the landing, some of the various tasks the rover is going to have once it actually gets to Mars. And then we're going to discuss a couple of other experiments that have been sent along with the rover, and then how you can participate and watch this event. First of all, I do want to let you know I am a NASA Solar System Ambassador. And so essentially what that means is that I am a volunteer for NASA, and we are people from all over the country who come from all different walks of life. Some people are amateur astronomers. Some of us work in museums. Some of us are teachers. Some of us teach in universities. We are a very wide, diverse group of people. And if you look at the left-hand side under where it says ambassadors, there are over 1,100 of us throughout the country. And our main job basically is to share the science and the excitement of the different programs that NASA has with the people in our communities. All right, so Perseverance was launched from Cape Canaveral on July 30th of 2020 with this rocket. This is a picture of the actual launch. And as I said earlier, it's been on a 6.5 month cruise to get to Mars. And it's getting pretty close. From when I looked last night, this picture is as of last night, the trip was 98.9% completed, and it still is over 3 million miles away from Mars. Well, that was as of last night. I think today it's under 2 million. And you can see that it's traveled a distance of over 289 million miles to get to Mars. That doesn't blow your mind. I don't know what does, but it's getting really close, and we're getting really excited for this landing. So this slide, I thought it would be helpful for you to see where Perseverance is going to land on Mars compared to the different other landers and rovers that have actually landed on Mars. So this is going to be landing at Jezero Crater, which is right by that longer black smudge, if you will. And there's a very good reason that they chose that landing spot. It is landing at Jezero Crater, which is an ancient delta. And scientists think that at one time, this used to be a lake. Over on the left-hand side, if you see that black ellipse, over to the left of that, you'll see like a little channel. And scientists think that at one time, that was a river that would drain into this delta area. And then it would drain out the other side if the lake got too full. So this area contains a lot of clay and other sediments that they think could hold keys to past life on Earth. And a delta, which is kind of like that fan-shaped area right in there by the ellipse, that's a structure that forms when sediments enter from rivers through open channels, and it just deposits sediments and sand and rocks in the lake. So by studying the rocks that are here, scientists think that they will have a better idea of how Mars evolved. So this picture is actually the configuration that the rover is in right now. And I think it's important for you to see these different pieces, because we're going to talk about these in a couple of minutes as we go through the entry, descent, and landing. So that piece right on top is the cruise stage, and that's kind of what helps it get to where it's going right now. The piece below that is the aeroshell, and that is protected from the harsh environment of Mars. The next piece is called the descent stage. And this piece has the rocket thrusters and also a neat thing called a sky crane on it. And the rover is attached to that piece. And then that bottom piece, that yellowish gold piece, that is the heat shield that will also help protect it as it's going through the atmosphere on Mars. So I think, it's helpful to see these pieces so that when we go through these next steps, you kind of have an idea of what these pieces kind of look like. And I'm not going to go into this picture a lot, but this picture basically shows the different steps that this rover has to go through to land on Mars once it reaches the Martian atmosphere. The rover is going to take about 7 minutes to land once it gets to Mars atmosphere. This is known as the 7 minutes of terror. And it's a period of time when the rover is going to be attempting to land on Mars, but with absolutely no help from NASA. The signal from the rover is going to take about 11 minutes to reach Earth. And in that amount of time, the rover could have safely landed or crashed on landing. So once the rover gets near Mars, it's actually going to be communicating with an orbiter that is up there called the Mars Reconnaissance Orbiter. And then from there, the information that Perseverance sends to that will be relayed to NASA's Deep Sky Network, which is a series of radio telescopes around the country and across the world. And then from there, the information that is sent will go to the Jet Propulsion Laboratory, JPL, to the mission team. So any signals that come from the rover has to go through a couple of different steps before it actually gets here. So the rover is actually going to be entering the Martian atmosphere at roughly 12,500 miles an hour. So in order to slow down enough so that it can land safely, it has to get rid of the cruise stage, which is that very top piece, and that contains solar panels, fuel tanks, and radios. Okay, so then at this point, now that it's gotten rid of that piece, it's just got the aeroshell and the heat shield to protect it. So as the rover is coming through the atmosphere, it slows down a little bit due to the drag, but at the same time, that slowing down causes things to heat up dramatically. And at its highest, the aeroshell and heat shield will reach about 2,370 degrees. The rover, being safely protected inside, will be staying at about room temperature until it lands. So during its journey through the atmosphere, the rover is going to encounter pockets of air that are more or less dense than the atmosphere, and it's going to try to push it off course. So to correct this and stay on track, it's actually going to fire some small thrusters on the back shell, and that'll help it adjust the angle and keep it on track. And the heat shield is going to help slow the rover down to about 1,000 miles per hour. And keep in mind, this is all happening in the course of about 7 minutes. So at this point, there's a new piece of technology called range trigger that's going to come into play. So range trigger will release the parachute that is on top of the aeroshell. In the past, they used to release the parachute as soon as it entered the Martian atmosphere. So the parachute is going to help slow it down even further. And this happens about 240 seconds into entry. About 20 seconds after the parachute is deployed, the heat shield is discarded. So once the heat shield is gone, the rover is actually exposed to the elements, and it can begin using its cameras and other instruments to take pictures and send back some data to the scientists. Now, I do want to point out one thing here. on the bottom of the rover here, there's a black piece that looks like a sideways sombrero. I'd like you to keep that in your mind as we go through the presentation, because we're going to talk about what that is a little bit later. Okay, so there's another new piece of technology, and this one is called terrain relative navigation. So this is basically a series of cameras on the rover. And so how this works is Perseverance already has pictures of the potential landing site stored in its computer. As the rover is beginning to land, it's going to take pictures of the landing site, and it's going to compare those pictures to the computers that are on the computer on board. And if it sees that this is a hazardous site, like it's a cliff, or there are boulders, or it's a huge crater, it can actually decide to land someplace else, and it's going to keep doing this until it finds a safe landing spot. So this is something that would not have happened with the Curiosity rover when that landed back in 2012. So back then they had to actually land the rover in a safe spot farther away from the spot it's going to explore. But in this case, we should be able to get closer to the desired spot, which will save the rover hours or even days worth of driving. And that means that the rover is going to have more time for science. Okay, so the parachute is only going to be able to help slow the rover down so much. At some point, it needs to lose the aeroshell and the parachute and use rockets to help slow it down, which is what you see in this picture. Think of the rockets as like a jetpack with 8 rocket engines pointed down. This is actually the beginning of the descent stage. So at this point, the rover is about 6,900 feet above the surface. So the rover separates from the aeroshell, and what you see here is the rover with the descent stage engines. And while this is all happening, it has to move one way or the other to avoid colliding with the parachute and the aeroshell. So at this point, the rover is slowed down to about 1.7 miles per hour. And then at this point, this is where the sky crane is used. This is going to happen about 66 feet above the surface of Mars, only 12 seconds before landing. The descent stage is going to lower the rover on a set of cables that are about 21 feet long. As this is happening, the rover is moving its legs and wheels into landing position. So as soon as the rover lands, it's going to cut the cables once it senses that it has actually touched down, and then the descent stage will fly off in a different direction to stay out of the rover's way. Whew. Okay, so that's what the 7 minutes of terror is all about. And at this point, it's not a given that this rover is going to land. A lot can happen that could actually prevent this from landing, and we could have a crash landing instead. But I would like to shift a little bit now, and we're going to talk about surface operations, which is what happens when the rover actually lands on the surface of Mars. So the Martian day is called a SOL, S-O-L. And the rover, actually, the Martian day is 24 hours, 39 minutes, and 35 seconds long. So the mission team work days will revolve around the SOL. Their workday is going to start 40 minutes later each day so that they are on the correct time with the rover. The team is only going to do this the first 90 sols because that is very difficult on a person's body to work shifts like that for a long period of time. So the first 16 sols is going to be used to begin imaging the landing site. They're going to upgrade the rover's flight software, do health checks on the various instruments, check out the mast arm, which is that like head that's pointed up, and they're going to try a short test drive. So if you remember, I was talking about that black piece that looks like a sombrero underneath the bottom of the rover. Well, the last thing it's going to do is drop that black piece, which is the belly pan. That belly pan has been protecting Ingenuity, the Mars helicopter. Yes, there is a helicopter traveling to Mars. So it's going to try to do some test flights with this, but it's not going to be right away. It's going to need to drive to a flat spot so that it can drop the rover and roll away from the helicopter. And then the mission team is going to try to perform some different test flights. So this picture actually shows the rover in its configuration when it's attached to the rover. So the blades are those two black and grayish things that you see there. And you can see two of the black legs of the rover. And then that silver piece that's above the two legs, that contains its computer and solar panels and other things that it needs. Okay, so this is what Ingenuity, the Mars helicopter, actually looks like once it's away from the rover. So the team that's working with the helicopter will have 30 sols to try experimental test flights with the helicopter. If they are successful, this will be the first powered flight on another planet. And it's completely experimental. This will be deployed about 60 to 90 days after Perseverance lands. The cool thing about a rover, and if this works, it would be able to explore cliffs and even caves that would be very difficult to get to with a rover. From what I was reading today, it's going to try up to, I think, 5 different flights, and they're going to be about 90 seconds apiece. And that's really not very long, but it's an experiment. So the goal is just to see if this is going to work. And being that Mars has a very, very different atmosphere from what Earth does, when they were creating this, the engineers really had to try to figure out how this would work in Mars atmosphere. Okay, so I would like to just discuss a couple of the different goals of the mission. There are 4 basic goals for this mission. So they're looking to identify past environments that are capable of supporting microbial life. They're looking for signs of past possible microbial life, especially in certain types of rocks. It's going to try to collect rocks and soil samples and then store them on the Martian surface. We're going to talk about that a little bit more later. And then there's also an experiment that is flying with it that's going to try to make oxygen out of the Mars atmosphere. Okay, so this picture, I want to briefly just go over some of the different instruments that are on the rover. We're going to start over on the very right-hand side with an instrument called Pixel. So this is located on the end of the robotic arm. It's an X-ray fluorescence spectrometer. And that's going to help determine the composition of the surface of Mars. It can detect signs of past life by looking at changes and textures in minerals. The next one up from that is called Sherlock. And That is going to look for organic compounds in rocks and surface materials. It's a different type of spectrometer, which can do fine scale imaging, and it uses an ultraviolet laser to detect minerals and organic compounds. So it's going to look at rocks and other minerals and surface soils to see if anything has changed over time. Also on the end of the robotic arm is a camera called Watson. So that is going to be able to record and magnify textures of rocks and soil, and it can send those pictures back for scientists to look at. It's also going to be able to take pictures of instruments underneath the rover and the wheels, so that scientists can kind of take a look at the health of the rover, if you will. So the next one over is on the masthead, and that one is called Supercam. And basically that is a laser that can fire, it can fire laser at rocks over 20 feet away. And it also acts a little bit like a weather sensor because it can measure air and molecules, water, ice, and dust. And it's also going to be able to measure elements in the air that could be harmful to humans. Keep in mind that Mars' atmosphere is mostly carbon dioxide. So the next one over from that, also on the masthead, is called Mastcam Z. And this is also a high-powered camera system with the ability to zoom. So it's going to serve as the rover's eyes and also kind of help it get to where it needs to go. The last one over on the left is called Rimfax, and you can't really see that one in this photo because it's underneath the rover. It is radar that can penetrate the ground and provide resolution of the soil and different rocks and other things that it finds. One cool thing about Perseverance is that it has a total of 19 different cameras on it. So we will eventually be getting a whole lot of different pictures from the rover as it's traveling about Mars. So there are two other instruments called MEDA and MOXIE, and we're going to look at those on the next two slides. Okay, so MEDA is basically the weather station for the Perseverance rover. And I was really having a very tough time finding a good picture of this. So those little areas that you see in yellow, those are all parts of MEDA. It's going to measure wind direction and speed, humidity on the planet, and it's also going to measure the size, shape, and amount of dust that's in the atmosphere. Dust plays a very, very big part in the temperature and atmosphere on Mars. So it's crucial to our understanding of the planet. Dust is everywhere on Mars, and we have to be able to protect future spacecraft and spacesuits from this. The rover is also carrying another experiment, which is called MOXIE. This is the one that's going to attempt to produce oxygen from the carbon dioxide in Mars' atmosphere. So MOXIE is that gold colored box that you see, and this picture was taken as it was about ready to be put into the bottom of the rover. It's about the size of a car battery. So it's going to try to make oxygen, but in order for us to do this for a manned space flight, it would need to be at least 100 times larger. But this is just an experiment. If it works, scientists will be able to move on from there and work on something larger now that they know that this actually works. So the other thing that this is carrying is samples of spacesuit materials. And the goal for that is just to be able to determine which materials hold up better in the harsh environment on Mars. So now I'd like to talk a little bit about the sample caching system that is on the rover. This is the first rover that actually has a device like this on it. So it's going to be able to take samples of rocks and drill below the surface. The arm of the rover actually contains about 20 different drill bits. So it can move those around to decide which one it wants to use. And then it's able to pick up those samples and store them in lipstick-sized tubes and seal them. And then once it's ready to, it can leave all of those samples on the surface of Mars. And someday there's a Mars return mission that is already in the works that is going to go to Mars, pick up those sample tubes, and bring those back here for scientists to study. For as much as we can do on Mars, we have so much better equipment on Earth to be able to study the samples. All right, so now that we've studied the rover, I want to share with you some of the fun things that NASA has been doing to get people to participate and get excited about the rover's landing. One thing that they did last year, they allowed you to submit your name to NASA to be included to fly with the rover. So if you look at the picture on the bottom right where that little arrow is, this is actually a piece on the rover. There's a piece that has 3 little chips right where that red arrow is pointing. That little piece has 10.9 million names engraved on it. So NASA decided that this would be kind of a fun way to get people involved in this. So I submitted my name, and then in turn, they sent me this really cool boarding pass. Now, I can't exactly take the boarding pass to NASA and say, here, I want to fly along. You can't do that, but it's kind of a fun nostalgia thing to be able to say, hey, look, my name went to Mars with the Perseverance rover. Now, you can't send your name along anymore because obviously those names are on their way to Mars, but you can actually go out to NASA's website and sign up for the next mission, which will probably be that return mission going back to Mars to get those sample tubes. So some ways that you can participate. I put this link out here where it says go to, and if you want, go ahead and copy that down. NASA has a whole bunch of fun things out there for you to do. There are different, there are lesson plans. You know, if you're a teacher and you want to do some of this stuff with your students, there are craft activities for kids. There's a way cool interactive toolkit, which you can download, and it will allow you to download like the stickers, like you see there on the right-hand side, that triangle. And there's a really cool interactive rover. And I'm sorry, I can't show you what that looks like, because if I try to do that, it'll ruin my presentation. But there's just a whole bunch of fun stuff. If you go to that link, look at some of the different fun things that they have. There's a NASA social out there that you can get involved in. And before the days of COVID, a NASA social is an event where they would invite people to come to their facility, and you would get like behind the scenes tours and meet some of the scientists that are working with the rover, you know, get to talk to some of these people. But because of COVID, it all has to be done virtually now. So basically there's a Facebook group set up, and you can join that Facebook group and talk to other people that are interested in the rover. I know NASA has been, today they had some different presentations going on, talking with some of the different scientists that are working with some of the different parts of the rover, and kind of explaining what those parts do, what they hope to gain from it. Some really cool stuff out there. So I encourage you to go and look at that link and just take a look at all the different stuff that NASA has put out there for you. But above all, NASA wants you to watch. So the rover is landing February 18th. Coverage is going to begin at 1:15 p.m. Central Time. So you can watch this by going to NASA TV, nasa.gov/live. NASA has also a YouTube channel. You can see it there. And also their Ustream channel, if you know what that is. And the other thing I just heard about, some of the different landmarks, like the airport LAX, apparently they are lighting up their building at night in red. And I believe the Empire State Building is going to also, to kind of celebrate the landing. And they're encouraging people to wear the color red to share their excitement over the landing. Well, my shirt is black, but it has Perseverance on it, so I'm going to wear it anyway, just because this is such an exciting event. And truthfully, I don't know how much we will exactly be able to see as it happens, but we'll be able to see the mission team in mission control and kind of hear different things that are going on, like when they're talking about, okay, so we just got word that the parachute and the aeroshell have dropped off, confirmation of landing. So I really think that this is going to be a fun, exciting event. And last but not least, if any of you have questions, I would be very happy to try to answer them. Just a little word about this funny picture here. The little stuffed Mars, he is what they call a celestial buddy. They have a whole line of stuffed critters for all of the planets. And I think there's even a comet and an asteroid in the bunch. And then that little rover is actually a Hot Wheels rover that is the Perseverance Rover, as much of a likeness as they could make. And I guess you can find that nowadays in some of the toy stores or maybe even Walmart. So if you're so inclined, you can look for those. Those are going to be a pretty hot commodity. All right, so does anyone have any questions?
Great, thank you so much, Joyce. And again, if you have questions, you can enter them in the chat, or if you would like to ask your question out loud, you can request to be unmuted, and I will unmute you so you can ask your question.
Okay, ask away.
Let's see, I don't see anything in the chat yet. I have been sharing some links though, some of the links that you had on your slide and that you had mentioned.
Oh, great. Thank you.
Want to grab them from there. No problem.
Thank you. I appreciate that. Any questions?
I guess you covered it quite well, Joyce.
I guess maybe I did.
And well, where again, I didn't catch where you said you could get that little stuffed planet on the last.
Okay, so those are sold through, I know Astronomy Magazine, their science shop carries them. And I believe if you just go onto Amazon, you can type celestial buddies, and it'll come up with you can find them on there too. I
Awesome.
think most of them run about $21-22 a piece. They're pretty cool. I have about half of the solar system sitting in my living room.
Yes, they are really neat. I'm gonna have to look into getting myself one. All right, so it looks like we do have a question here. Will these be the first samples from Mars that we return to Earth?
Yes. Yes, this has never been attempted before.
Okay. And again, those samples won't be coming back until another mission is.
Well, yeah, they're currently beginning to work on another mission. It might be 2030 before those samples get back to us.
Oh, wow. Okay.
Yeah, it's going to be a while yet.
Great. Yes. All right. Any other questions? I don't think.
Okay, I see Mohammed has raised his hand. Do you have a question, Mohammed?
Oh, here, I can
Unmute.
unmute. All right.
Yes, hello, and thank you very much. You said the samples are stored in a lipstick container, but where is that container going to be put? Is it on the rover, or, I mean,
Well,
where is it going to sit for the next
right
10
now-
years? Or...
Right now, those are stored on the rover. And so as it fills these sample tubes, for the time being, it's going to put them back on the rover. When it has all those 30 different sample containers filled, then it's going to figure out where on the surface to put them. But it may not do that right away, just because Mars tends to get a lot of dust storms. And
yeah,
if you can imagine this over the course of what we have 10 more years possibly before we might be going back there, they might be covered in dust and buried by then. So I have a feeling it's probably not going to put those on the surface for quite some time.
okay, thank you.
You're welcome. All right, anything else? Okay, so Katie, I'm thinking that might be it.
Yes, and just a reminder, we will be posting the recording of this presentation on the library's YouTube channel. I did share the link for that earlier on in the chat. Thank you so much, Joyce, for the wonderful presentation. We love hosting you here at the library.
You're welcome.
We hope to learn more about the upcoming rover missions as well in the future from you. So keep an eye out for that, everyone.
Okay, thank you.
And thank you, everyone, for attending tonight. Have a good night.
All right, thank you, everybody.